So we continue our lesson on matrices by looking at the determinant of a matrix in this particular lesson video. So we continue nice and slowly by looking at a 2 by 2 matrix as a beginning guide for determinant of a matrix. So let's say we have matrix A to be equal to, let's say we have A, B, C, and D. And we are asked to find a determinant of this matrix, say A. So how do you find that? We will say that A should be equal to, so that's what we're going to do. We'll find what? The product of the downward diagonal, okay? And then compare that to the product of the upward diagonal. By this way, we mean that we'll find what? The product of what? A and D. Compare that to the product of what? B and C. This is how we find a determinant of a 2 by 2 matrix. Let's take an example to support this concept. So let's say we have matrix A to be equal to, let's say we have 4, 3, -1, 2. And we are asked to find a determinant of A. How do you go by this? We will say that A should be equal to, so what are you going to do here? So here you have what? The product of what? Your downward what? Arrow. Compare that to the product of what? Your upward what? Arrow. X in that line. So what are you going to do? We'll therefore say that the determinant of A should be equal to 4 multiplying 2 minus. Then we have what? 3 multiplying -1. What are we getting? 4 multiplying 2, we are getting 8 minus 3 multiplying -1, we are getting what? -3. So in its effect, negative meeting negative, we're going to get fetch as what? Positive. So we are going to get what? 8 plus 3, and we are getting what? 11. This is how we find the determinant of a 2 by 2 matrix. So let's take note of that. Now we want to talk about determinant of a 3 by 3 matrix. How do you also find the determinant of a 3 by 3 matrix? So we look at 3 by 3 matrix determinant. So now let's say we have X to be equal to, say A, B, C, D, E, F, G, H, and I. So we are asked to find the determinant of what? Matrix X. How do you find that? By a 3 by 3 matrix of finding the determinant, this is what we're going to do. In finding the determinant of a 3 by 3 matrix, we'll repeat the first 2 columns to be part of the main matrix given in question. We repeat the first 2 columns of the matrix to be part of the main matrix given in question. So we'll therefore say that we have X to be equal to, so we're going to have here to be what? A, D, G, right? Then we have B, E, H, then we have C, I, and what? Sorry, C, I, F, and I. But a 3 by 3 matrix, for us to use the arrows or the product of the arrows to determine the determinant, we will need to repeat what? The first 2 columns for the matrix in question. So we repeat what? A, D, and G. And we also repeat B, E, and what? H. So that we get the whole of what? This matrix. So once you're able to get this by the repetition of the first 2 columns of the original matrix in question, then we can move straight to find our determinant. So by using the product rule of finding determinant with reference to the arrows, we will say that X should be equal to, so this is what we're going to do. We'll have what? Our arrows. So we have A, E, and I, and also have what? B, F, and what? G. Okay, we also have C, D, and what? H. So that's going to be the 3 lines we're going to have as a diagonal. And when we come to the upward one, too, you can have what? G, E, and C. Then also you're going to have H, F, and A. You're going to also have I, D, and what? B. Okay? So once you're able to get this, then we will say that we'll find the product of what? The downward what? Diagonals, and then compare that to the product of what? The upward what? Diagonals. And I believe that is clear. So we're gonna say that we'll find the sum of the product of what? The downward what? Diagonals, and the sum of the product of what? The upward diagonals. We take the difference between the two, and we get the determinant of a 3x3 matrix. So we'll say that we have what? A, E, I plus B, F, G plus, then we have C, D, and H. So after that, we compare that to the product of the upward what? Diagonals, and we sum them up. So we have what? G, E, C plus, then we have H, F, A, okay, and then we say plus. Then we also have I, D, and B, and we close that, and we have our main bracket there. This is how we find the determinant of a 3x3 matrix using the product of what? The upward and downward what? Arrows. So let's take note. So let's take an example to actually explain this concept far more better. So example, let's say we have matrix X to be equal to 1, 2, 3, 4, 9, 2. Then we have 5, 1, 3. By using the product of the downward and upward diagonals, we will say that to find that of what? X, we need to repeat the first two columns of the original matrix, say matrix X, right? So we're going to have 1, 4, 5, we have 2, 9, 1, we have 3, 2, 3, and then repeat the first two columns of the original matrix X. So that's going to give us what? 1, 4, 5, then we have 2, 9, 1. Okay, so once we are done with this, then we have our arrows to be indicated in that particular case. So we have our downward what? Arrows. So any of the numbers that will form a proper downward arrow, you draw an arrow to indicate that we're going to find a product in that line. It's going to have what? The first one, pattern across 1, 9, then 3, right? And then we also have 2, another 2 here, and we have 5, and then we also have 3, 4, 1. So that becomes the downward what? The downward what? Arrows, and they also talk about the upward. So you have 5, 9, and 3. You also have 1, 2, and 1. You also have 3, 4, and then 2. Okay. So by this we will say that that X should be equal to, so what are we getting? We will have, so the product of what? The downward what? Diagonal. So we have what? 1 multiplying 9 multiplying 3. So we're going to have what? Here to be 1 multiplying 9 multiplying what? 3. Okay. Then you say plus. Then we have what? 2 multiplying 2 multiplying what? 5. Okay. The same thing actually. Then we will say that plus. Then we have 3 multiplying 4 multiplying 1. So that becomes what? That of what? The product of the downward what? Arrows. And then we talk about the product of what? The upward arrows. So we have what? Here too, we're going to have what? 5 multiplying 9 multiplying 3. So that's the first part. Plus, and we also have 1 multiplying 2 multiplying 2 multiplying 1. Okay. And lastly, we say plus 3 multiplying 4 multiplying 2. Okay, then we have a big closing bracket. So what are we getting? We say that X should be, so here when we multiply 1 by 3 by 9, you're going to get what? 27. Plus 2 by 2 is going to give us 4 multiplying 5, you're getting 20. Then we have 3 by 4 by 1, we are getting 12. So close the bracket, minus, and come to this side. 9 multiplying what? 5, we are getting what? 45. 45 multiplying 3, what are we getting? Get what? 6. Then we are getting what? 135. So that's going to give us what? 135 plus, and here we are getting what? 2 plus, and here we are getting what? 3 by 4, we are getting 12. 12 multiplying 2, we are getting 24. Then you sum them up. What are we getting? 20 plus 20, 27 plus 20, we are getting 47. 47 plus 12, what are we getting? We are getting what? 59. So we're going to have here to what? 59 minus, and we add 35. 135 plus 2, we are getting 137. 137 plus 24, we are getting what? Here we are getting 6. Then we are getting what? 161. 161. So 161, taken from 59, what are we getting? 161, 59. So here 11. We're going to fetch here 2. We are left here with what? 5. So here we're going to fetch us what? 0. And we are getting what? So we are getting 1, 0, 2. So meaning that our determinant x is going to give us what? Negative 1, 0, 2. So this is how we find a determinant of a matrix considering a 3 by 3 matrix. So let's take note of that. So thank you for watching. The video was really helpful to you. Please go ahead to smash the like button on the video, subscribe to the channel, and share. And I will see you in the next video where we discuss other questions in relation to matrices. Bye-bye.